Scientists and inventors are always searching for research problems. Do you wonder how do they find these research problems? Let's see what C.V. Raman has to say. C.V. Raman liked a lot of musical instruments. He was fascinated by not only their aesthetics, but also the acoustics of those musical instruments. His motivation was to actually study the physics behind these fascinating acoustical instruments, and he studied many Indian classical instruments and also some Western classical instruments. He was mainly motivated by one of his heroes, Lord Rayleigh. Lord Rayleigh himself was fascinated by various natural phenomena. For example, one of the fascinating questions Rayleigh was very interested in is to address why is the sky blue. He was also very fascinated by phenomena of sound. In fact, he addressed this question in significant detail, and the definition of the question was, how does sound propagate in a particular medium? Rayleigh undoubtedly was one of the greatest scientists in classical physics. If you just take any physics textbooks, you will see multiple pages of interesting discussion related to what Rayleigh had done in the past. He also did an outstanding kind of research on sound, and a masterpiece was written by him, and the title of that particular book is called as The Theory of Sound. This particular book discusses natural phenomena of sound. Specifically, it was written in 1894, and it still is of very high relevance because the physics is so sound and so interesting. In that particular book, Rayleigh made a very interesting observation, and that observation was related to a very fascinating architecture in London. And that particular architecture was the St. Paul's Cathedral and its magnificent dome. This dome actually has a gallery, and if you whisper at one particular place in this gallery, it can travel around that particular dome and you can hear that sound. And that sound, which is resulting in people hearing even very tiny whispers, is due to a phenomena called as whispering gallery waves. Whispering gallery waves generally are described as a type of waves that can travel around a concave surface. So if you have now a talker at a particular place along this particular gallery, which is in dome shape, then the sound will propagate in such a way that it will reach the listener at a faraway distance in this particular gallery. Even tiny whispers actually can be heard. Now, there is also some fascinating simulations one can do. In this particular case, thanks to Oliver Wright and his colleagues at Hokkaido University in Japan, they have also kind of simulated how does the pressure waves move in this particular situation, for example, in St. Paul's Cathedral. So what you see as the red and the blue colors are essentially the compression and the rarefaction of sound and the propagation of that sound in that particular medium. And notice that the sound doesn't go into the center, but is kind of creeping in the periphery of this particular gallery. And that's the reason why sound propagates in a very fascinating way called as the whispering gallery waves. Rayleigh himself wrote research papers on them. In fact, he quantified this particular phenomena and gave a very interesting mathematical turn. He brought in the Bessel functions and made some very fascinating observations related to this particular phenomena. And he elaborated whatever was written in his textbook and further gave some clues on understanding this particular phenomena with significant detail. C.V. Raman, who was vastly inspired by Rayleigh, followed his inspiration, and he visited London in 1921. And he went to St. Paul Cathedral and repeated some of the experiments what Rayleigh had suggested in his interesting book and also in research papers. In fact, this culminated into a wonderful research paper which C.V. Raman and Sutherland wrote together on understanding the whispering gallery waves in this particular place, the St. Paul Cathedral, which is the very place which Rayleigh had mentioned in his books and in his papers. Furthermore, in 1922, Raman explored whispering gallery modes now in India, British India in that particular time. So he then culminated his studies into this wonderful research articles titled On Whispering Galleries. And this is where he makes one of the very interesting observations, and he puts it on the paper on the description of Gol Gumbaz at Bijapur, which gives rise to these fascinating whispering gallery waves. In addition to Gol Gumbaz, he also studies Victoria Memorial at Calcutta and a granary at Bakipur in Patna, which is in Bihar, and also the Calcutta General Post Office shows whispering gallery waves. So Raman essentially was hunting across India to see which particular architectures give rise to this fascinating phenomena of sound. In fact, he writes in this particular paper that among the Indian whispering galleries, the most notable architecturally and acoustically is the great Gol Gumbaz at Bijapur. In the Victorial Memorial recently completed at Calcutta, there are two very fine whispering galleries, one of which, curiously enough, remained unsuspected till it was discovered by the writer. So he's now going on to say that he has been able to discover this whispering gallery waves in these new buildings which are coming up in the British India. Interestingly, he also makes a nice observation where he says that there are also acoustic curiosities in other tombs like Fatehpur Sikri near Agra, and this particular paper does not discuss that, but Raman does make a mention of this particular fascinating phenomenon. So Raman wrote in his paper about Gol Gumbaz in the following way, and another remarkable feature in the building is its whispering gallery, which runs round inside the dome as its base. On entering the building, a person is struck by the loud echoes which fill the place in answer to his footfall, but these sounds are intensified on entering the gallery. The footfall of a single individual is enough to wake the sounds as of a company of persons, and in response to ordinary conversation, strange, weird sounds and mocking whispers emanate from the wall around. Stop quote. This is a beautiful description of C.V. Raman in the research paper what he's writing about Gol Gumbaz and the whispering galleries in Gol Gumbaz. And this figure what you see in this particular video is from his research paper, and you can see that he has a deep appreciation of the kind of architecture which the Gol Gumbaz is. C.V. Raman was indeed fascinated by Gol Gumbaz. His paper brought in a way physics, architecture and history together on one single platform and combined science and arts very, very fantastically. In a way, he brought aesthetics to be objective and objective to be aesthetic, which is quite intriguing and fascinating in terms of how researchers look at the phenomena. So, WGM, which is the whispering gallery modes, these are very fascinating, and you may of course ask, is it just a curious observation? What is the use of all these things? It might be just a normal curiosity-driven question. Is there any application? There's a lot of research which is going on in this particular field. In optics and photonics, what started as a fascinating phenomena in acoustics, which is a study of sound, has turned out to be of great relevance in optics and photonics research. So shown here are the two interesting research papers which have been written, a kind of review articles of how whispering gallery modes can be utilized for various different optics and photonic applications. So much so that you can now create spherical whispering gallery mode micro resonators, which can give rise to sharp resonances, and they can lead to lasers at micro and nanoscale. So what started as an optics research has now turned out to be extremely useful in optics and photonics. It's not just optics and photonics. There's also many interesting applications in acoustics, astronomy, materials engineering, and various different interesting questions related to how spherical cavities can behave and be utilized. In my own research group, we have been actually interested in knowing how whispering gallery modes behave in dielectric spheres. And these spheres can be few microns in diameter, and they have a specific refractive index, roughly about, let's say, 1.5. If you incident light onto such particular sphere, the light gets very interesting kind of behavior in this particular sphere. The light goes round and round because of the so-called whispering gallery modes. There is also kind of total internal reflection involved in this. Please note that the whispering gallery modes in optical phenomena may be slightly different from the way it behaves in the sound phenomenon. So what is interesting is that you can now confine light in certain cavities, such as the spherical cavities, and because of the confinement of light in such spherical cavities, they lead to very sharp resonances. And such sharp resonances, where you can see this peak as a function of wavelength, can lead to some very, very fascinating applications, because sharp resonances can act like very sensitive sensors of objects around the environment in which this cavity is present. We have been actually exploring this topic for a while and learning new things in our laboratory. So if you're interested, please do check out all these papers, what we have written. And there are some fascinating questions related to 2D materials and plasmonic phenomena, etc., etc. So going back to the question we started, how do scientists find interesting research problems? In the context of C.V. Raman, he was inspired by the natural phenomena. He studied musical instruments. For example, he also studied mridangam and was trying to visualize some wave patterns on the surface of the mridangam, and he did a lot of fascinating experiments. He also was inspired by the beautiful architectures like Gol Gumbaz, Victoria Memorial, and also St. Paul Cathedral, etc., etc. So in that way, he derived his interest from various different phenomena which was there around him, and he was a keen observer. The world was his laboratory. C.V. Raman's world was his laboratory. And isn't it a wonderful way to find interesting research problems? Indeed. Please share and subscribe to our YouTube channel, Science Meets History. I hope you like this particular video. Until next time, bye-bye.